So what does the first question say?
Identify the element with atomic number 5.
Oh, so use the periodic table to help you answer this question. They're saying identify the element with atomic number 5. So that is obviously going to be boron. So boron is the element that has atomic number 5. Boron is the element in the periodic table that has atomic number 5. And we actually know very well that atomic number is the same as the number of protons, isn't it? So the atomic number is the same as the number of protons, isn't it? And we said proton number, isn't it, is equal to the electron number. So proton number is the same as the electron number, or atomic number is the same as the number of protons. So the atomic number of an element is the same as the number of protons. And in any atom of an element, the proton number is always equal to the electron number. That's why an atom is always neutral. An atom is electrically neutral. So if it has 5 as its atomic number or number of protons, then that means the number of protons is 5. And obviously the number of electrons is 5, isn't it? If protons are positively charged and electrons are negatively charged, then that means if this has to cancel with this one, then the resultant charge is 0. Yeah. They are saying give the symbol of a metallic element in period 3. The symbol of a metallic element in period 3.
Sodium.
Yeah, you can say sodium. Someone else can say magnesium. Someone else can say aluminium. So the first element, isn't it, in period 3. Of course, if this one becomes my periodic table, we'll obviously know that now these are groups, isn't it? 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, then 8. So we have the first period, the second period, the third period, and 1, 2, 3, 4, isn't it? So this is the first period, isn't it? The second period, the third period, and the fourth period. So the first period, second, third, fourth. Then the group, the first group, the second group, the third, the fourth, the fifth, the sixth, the seventh, then the eighth. So these are called group 8 or group O elements, isn't it? Group 8 or group O elements. Very good. Now, yeah, so this is period 3. So you need to have sodium, you have to have magnesium, you have to have aluminium, and of course others like number 14, which is silicon. Then number 15, that is phosphorus. Number 16, that is sulfur. Number 17 is chlorine, and number 18 is argon. But they talked about elements, of which are metallic, isn't it? So we'll talk about sodium as a metal, magnesium as a metal, aluminium as a metal. You see? And that gives us now a simple summary of that in terms of the chemical formula. So you're going to write capital M, small g, capital N, small a, capital S, small l. They're saying identify the element whose atoms contain 14 protons. Identify the element whose atoms contain 14 protons. That is
Silicon.
That is silicon. Good. Silicon. That is actually to say the element that has to occupy position 14 in the periodic table is silicon. So you actually write capital S, small I. That is silicon with atomic number 14. With the number of protons is what? 14. And that is also equivalent to the number of electrons in the same atom of this element called silicon.
1, 2, 3, 4, 5, 6, 7, 8.
Up to 14, yes. Then they're saying, of course, it's going to be in which period and which group? It's going to actually be in 2 to 8 to 4. So that's going to be group 4. isn't it? In period what? 3. So it has 4 electrons in the outermost energy level to actually give us group 4. Then 3 energy levels to give us period 3. 3 energy levels to give us period 3. Okay, so something else they're saying, identify the element whose atoms have the electronic configuration 2 to 5. The electronic configuration 2 to 5. That is very simple, isn't it? So 2 to 5, that is nitrogen, isn't it? Because if it has an electronic configuration of 2 to 5, that means it's actually going to have 7 electrons. So use electrons to actually write what we call the electronic configuration. So if it is 2 to 5, that means 2 plus 5 is 7. So each electronic configuration is 2 to 5. So each number of electrons is 7. So if it has 7 electrons, that means it also has how many electrons? 7. And the exact number of electrons has to give us the number of protons. So 7 electrons. So it still has 7 protons. So that element with an electronic configuration of 2 to 5 is nitrogen, because its atomic number is 7, or the number of protons is 7, which is equal to the number of electrons, which is also 7. They're saying identify the name of the compound formed between oxygen and the element with atomic number 13. Oh, that is going to be aluminium 3 oxide, isn't it? You have oxygen, that is 2 to what? To 6, isn't it? We have aluminium, that is 13, which is going to be what? So 13, let me start with this one. We can say, let's start with the metal, that is aluminium. Then we can go to now the non-metal, which is oxygen. Aluminium 13, isn't it? That is 2 to 8 to 3. Oxygen 8, 2 to 6. So I'm going to write 3 positive. That means this reacts by losing how many? 3. I'm going to write 2 minus. It reacts by getting 2. Then I interchange. So I'm going to have aluminium 2, then O3. That becomes the chemical formula. It's very easy. They're saying the next question. The position of an element in the periodic table can be used to predict its properties. Which group contains elements that are all unreactive? That is group O. So group O or group 8 contains elements that are unreactive. So group O or group 8 will contain elements that are unreactive. So we call these elements rare gases, or we can call them inert gases, or you can say noble gases, or they are literally inactive, so they do not gain or lose. They either have what we call an octet state or a duplet state. You must have heard of these things, octet or duplet. Octet means it has 8 electrons in the outermost energy level, from the word octagon. Duplet, how many electrons? 2 electrons in the outermost energy level. If you look at this one, this is mostly found in such an element like argon, which forms part of the components of what you call the inert gases, isn't it? Argon has 2 to 8 to 8. This is helium. So argon has an octet state, having 8 electrons in the outermost energy level. Helium has 2 electrons, so it ends up having what you call a duplet state. So group O or group 8, isn't it? Like helium, neon, argon, krypton, xenon, radon. Which of these is the least reactive element in group 1? The smaller the atomic radius, the less reactive the element is, isn't it? So the most reactive is potassium, isn't it? In the first 3, potassium, followed by sodium, followed by lithium, isn't it? But you can talk about francium, caesium, rubidium, isn't it? So if you talk about francium and caesium, you can easily be able to actually know that francium is the last element among group 1 elements or alkali metals. So in that case, it ends up being the most reactive. Why? Because it has a larger atomic radius. So having a larger atomic radius makes it to easily lose its loosely held outermost electron to the nucleus. The boxes list changes that may happen in a laboratory and the names of the changes. Draw one straight line from each change to its correct name. So
and your faithfulness each day.
ice turns into water.
Melting.
Melting, good. The ice we are just taking right now, it is actually turning into water. That is melting. Solid carbon dioxide turns directly into a gas. That is sublimation, isn't it? And of course, other things that can be able to sublime as well are like, sometimes I can ask you, give any other thing that can be able to actually undergo the same change that carbon dioxide has undergone. You see? Do you take ice cream? The cold boxes of the ice cream vendors has solid carbon dioxide or dry ice. So, dry ice. And you know what? They will ask you one day, why do you think dry ice is preferred over normal ice? We don't put this normal ice in cold boxes of ice cream vendors. You know why? When this normal ice changes its state, it leaves wetness, which becomes a problem in the cold box of the ice cream vendor. So you actually end up using the dry ice. This one sublimes, leaving no wetness. So other things that can be able to sublime, even iodine can sublime, isn't it? There's another one called camphor. This one also sublimes. There's another one called benzoic acid. This one also sublimes. Even naphthalene can sublime. You see, aluminium 3 chloride can be able to sublime, and hydrous calcium chloride, isn't it, has actually the least property. You see, or the smallest property of also being able to sublime. You see?
When I think upon your goodness,
iodine, camphor, benzoic acid, naphthalene, aluminium 3 chloride, iron 3 chloride, ammonium chloride are able to sublime or change their state. A solid is turned into a solvent. That is dissolving, isn't it? A solute. So we always say solute is the solid that gets dissolved in a solvent, plus solvent, the liquid in which the solid gets dissolved, will end up giving us a solution. So that is actually dissolving. Very easy. Chemistry is the easiest subject in the whole world. A student has two solids, X and Y. One of these solids is a pure substance and the other is a mixture. Describe how the student could identify which solid is pure and which is a mixture by measuring a physical property of each solid. You can use what we call the melting point and the boiling point, isn't it? That's what will be the answer. How do you do it? How do you do it to arrive at the answer?
See, boil them.
Yes?
Boil them and then boil it.
So you can say the two are actually able to undergo what you call heating. So they get first heated, isn't it? When heating gets done, the melting point and the boiling point of each is actually recorded, isn't it? The one that is pure must have a sharp melting point and a sharp boiling point. For example, when impurities are placed in a substance, the impurities lower the melting point and raise the boiling point. So pure water, for example, pure water has to end up boiling at 100 degrees Celsius and has to end up melting at 0 degrees Celsius. But if the water has impurities, it may end up melting at a temperature lower than this, and it may end up boiling at a temperature more than that. You can even have 110 degrees Celsius. That means the water has impurities. It doesn't have a sharp boiling point, neither does it have a sharp melting point. So it ends up having a melting point lower than 0 and a boiling point more than 100. It makes it to become impure. Very good. So if something is pure, it has a fixed or sharp MP and BP. If something is impure, it melts over a range of temperatures in the substance. Okay? Okay, so question
3.
Question 3. This question is about metals. Metals can be arranged in a reactivity series based on their reactions with water and their actions with diluted hydrochloric acid. The table shows how four metals P, Q, R, and S react with water and with diluted hydrochloric acid. So P with water, no reaction. P with diluted hydrochloric acid, the hydrogen gas forms very slowly. Q, no reaction, no reaction. Completely, so it does not actually react with water, and neither does it react with hydrochloric acid. R, hydrogen gas forms very quickly, and then with the acid, not done. So hydrogen gas forms quickly, hydrogen gas forms very quickly. Now, if you look at the first element P, it does not react with water, and neither does it react with what? Hydrochloric acid. That is obviously going to be maybe an element like copper, isn't it? Copper does not react with both water and hydrochloric acid because it's below hydrogen in the reactivity series, so it cannot displace hydrogen in any of the two reactants it may actually have to react with. Q, no reaction, no reaction. That may be even elements like silver, copper, or gold, isn't it? They'll completely not react with any. Then they're saying hydrogen gas forms very quickly when that element reacts with water. Then the reaction with dilute acid is not done. That must be a group 1 element like potassium, isn't it? Hydrogen gas forms quickly, hydrogen gas forms very quickly. So in that case, when it reacts with both water and hydrochloric acid, that may be still a group 1 element like sodium, isn't it? Or a group 2 element like magnesium. So they're saying identify which of the metals P, Q, R, or S could be gold. That is obviously Q, isn't it? Q. Then suggest why the reaction between metal R and hydrochloric acid was not done. It must be explosive. It must be explosive. Dangerous or unsafe? Unsafe. Yeah, who wants to die? No one. Very good. Nilikuwa nimepanga. So who wants to die? No one wants to die. Very good. Suggest why the reaction between metal R and hydrochloric acid was not done. So you have said it is very dangerous, very unsafe, or it is very explosive. Now, the next question they are saying use the information in the table to place the metals in order of reactivity from the most reactive to the least reactive. Now, we have 4 metals. Which one becomes the most reactive? So we have P, Q, R, and S. Which one becomes the most reactive? This one, whose reaction with the acid does not get done, isn't it? So the first one is R. The second, S. It reacts with the water to form the gas very quickly, which is hydrogen, and again reacts with the acid to also form a gas very quickly, isn't it? Then
P.
We will literally pick P because P reacts with the diluted hydrochloric acid to actually liberate hydrogen gas, but very slowly, but it does not react with water. But now Q will be the last one because neither does it react with water, and we will literally say that it does not again react even with what we call the hydrochloric acid. So R, S, P, and Q, the order of reactivity of those elements with both the acid and the water. There's a zinc is used to coat iron gates to prevent the iron from rusting. State the name of this method of preventing iron from rusting. You must have heard of something called galvanizing, isn't it? Or galvanization. The coating of a less reactive metal with a more reactive metal to prevent it from what? Rusting. Or sometimes some people call it sacrificial protection. Now they're saying state another method of preventing iron from rusting. Of course, you can talk about painting, isn't it? Painting, of course, using oil and grease or sacrificial protection. See. Question? Then they are saying a mixture of zinc powder and copper 2 oxide is heated. The chemical equation for the reaction that takes place is this. Show or state how the reaction shows that zinc is more reactive than copper. Of course, you're going to say, in this case, you have zinc what? And copper oxide. What shows that zinc is more reactive? Very good. So the copper gets reduced to this state, isn't it? In as far as its position in the compound is concerned. So the copper to oxide is reduced to copper metal. Then the zinc gets oxidized to zinc oxide. So the zinc displaces copper from this part. So it actually ends up getting zinc oxide as its new state. The copper to oxide gets reduced from this state to copper metal. So that, in other words, tries to tell us that now the zinc that is more reactive displaces copper from its oxide, isn't it? Then it forms now the zinc oxide as the oxide and then the copper metal as the metallic part. Of course, these are black solid, the copper to oxide, but now at the end of the day you end up forming what you call a brown deposit, which is actually the copper metal. Brown deposit of the copper metal. Imagine. Now, explain which substance is the oxidizing agent. Which substance is the oxidizing agent? The copper to oxide is the oxidizing agent. Copper to oxide oxidizes zinc to zinc oxide. Then itself is reduced to copper metal. So the zinc becomes the reducing agent, while the copper to oxide becomes the oxidizing agent. Good. So the thing, sodium hydroxide dissolves in water, forming a strongly alkaline solution. Ammonia dissolves in water, forming a slightly less alkaline solution. Identify the ion that makes the sodium hydroxide solution alkaline. That is the hydroxide. So hydroxide ions are responsible for the alkalinity of sodium hydroxide. They are responsible for the alkalinity of sodium hydroxide. Very good. So if you get anything like an alkaline or something that's basic, you should expect to find the OH, isn't it? What's the possible pH of ammonia solution? They say it's a weak what? Weak base or less alkaline. That must be something closer to 9. Yeah, the teacher says that from 1 to 3, that must be a strong acid. Then 4 to 6, maybe 6.5, that is actually a weak acid. Then 7 is what? Neutral. Then 8, 9, 10, 11, that's actually a weak base. But if you come from, let's say, 12 to 14, that must be what? A strong what? Base. Strong base. Question? We are almost finishing. Allah is great. When ammonia solution reacts with sulfuric acid, a neutralization reaction occurs and ammonium sulphate forms. How does the sulfuric acid act in this reaction?
Proton donor.
Proton donor. Acids are proton donors, then bases are proton acceptors, isn't it? Oh, proton donor. Very good. Very good. Now, so proton donor. Now, next is they are saying the diagram shows a beaker containing some ammonia solution and a few drops of phenolphthalein indicator. Ammonia solution and a phenolphthalein indicator. The dilute sulfuric acid is added to the beaker until it is in excess. What are the colors of the phenolphthalein indicator before and after adding excess sulfuric acid? Oh, very good. So if you have phenolphthalein indicator, phenolphthalein in an acid base neutral, we always say colorless, pink, then colorless, isn't it? If something like metal orange is used, you say pink, yellow, orange. That's actually metal orange. If it is something like screened metal orange, you say red, green, gray. You see red, green, then gray. That means the screen metal orange is actually red in an acid, green in a base, then green what? In a neutral solution. Metal pink, yellow, orange.
Red, yellow, orange.
You can either say pink or red. Next, ammonium sulphate is used by gardeners as a fertilizer because it contains nitrogen. Explain the chemical formula of ammonium sulphate is this. Refer to the changes or the exchange of the ions in your answer. Of course, you always say if you are using a litmus paper, it has to turn from red, blue, purple, isn't it? So we have ammonium ions and then sulfates. These are called radicals, a group of compounds that react, and of course they have to do this as a unit, and they have a net charge. So a group of compounds, isn't it? Or you can say a group of atoms that exist and react as a unit with a net charge. So you just exchange the charges or the ions. So you're going to have NH4, 2, then SO4. That's now ammonium sulphate. So calculate the relative formula mass of ammonium sulphate. It's very easy, isn't it? Nitrogen is 14, then you say times 2, isn't it? Then plus hydrogen, there are 4 times the molecular mass 1 times 2, isn't it? Then you have sulfur, that is 32, then oxygen is 16 times 4. What's the answer? That is 28 plus 8 plus 32 plus 64.
132.
100 and?
32.
So the answer is 132. Very good. 132. Calculate the mass in grams of nitrogen in 1 kilogram of ammonium sulphate. Yes, the answer is
7.5757.
sure. How do you get that?
1000 grams divided by 132.
Why am I doubting your answer? Why am I doubting your answer? Look at this. 7 point is not actually correct. Look at this. 132 grams per mole must be containing 28 grams per mole, isn't it? What about 1 gram? Isn't it? Isn't it? 132 contains what? Or you can decide to say if 132 grams contains 28 grams, what about 1 gram? 1 gram, isn't it? So it will be 1 times 28 divided by what? 132. This is the mass of what? 1 gram, isn't it? So if it's 1 gram, then that means what about 1,000 kilograms? Because they said 1 kilogram, isn't it? That gives you 212.12. Yeah, that's what you're supposed to do.
How am I wrong?
You say 7 point something. Chlorine, bromine, and iodine are elements in the periodic table. Explain how the position of these elements in the periodic table depends on their electronic configuration. Of course, it's very easy, isn't it? You just use one example. You'll say chlorine fluorine and bromine. Let me rearrange them. I'm going to have fluorine, chlorine, and bromine. This is number 7, number 17, because we have 9, 17, then 35. So you have 2 to 7, 2 to 8 to 7. If I'm not wrong, then this 2 to 8 to 18 to 7. That is bromine. So 10 plus 25, that is 35. So in as far as the position of the periodic table is concerned, they are all found in group what? Group 7. Why? They have 7 electrons in the outermost energy level. That makes them to be in group 7. So they all have the same number of electrons in the outermost energy level. Isn't it? And number 2, we look at the period. Fluorine is found in period 2, chlorine in period 3, bromine in period what? 4, because of the number of energy levels. Chlorine gas methane to form CH3Cl and HCl. So the condition necessary for this reaction, you have to have ultraviolet rays from the sun. The UV light from the sun will act as a catalyst. Now, what is the function of this? If you have, let's say, chlorine gas with methane reacting, we expect to have the atoms of the halogen getting split, you see, by the aid of what you call the UV light, the ultraviolet rays. The ultraviolet rays. So that means when they split, the atom on this end can come and displace hydrogen. So what do you end up having? CH3. So there's one hydrogen, then Cl, then plus HCl. Isn't it? So the work of the UV light is to split the atoms of the halogen so that displacement can be able to occur. So the UV light will act as a catalyst. That's why this reaction cannot occur in the dark, because of the absence of the UV light. So give the equation for the reaction. You have done that. It is actually here. This is a gas, this is a gas, of course gaseous state, and of course gaseous state. And that gives us now the final answer in as far as that part is concerned. Isn't it? The bonds in a molecule of CH3Cl are covalent. Explain in terms of the electronic or the electrostatic attraction what is meant by a covalent bond. A bond between two nonmetals where there's equal sharing of what? Electrons. Or, very good. We can just say a bond between two atoms where there's equal sharing of electrons in the outermost energy level. Very good. So they're saying, draw a dot and cross diagram for a molecule of CH3Cl. Show only the outer electrons of the atoms. You can do that, isn't it? They even draw the diagram there for you. Your work is to complete the diagram. Isn't it? So they're saying CH3Cl has a simple molecular structure. Explain why C3 has a low boiling point. A simple molecular structure must having, isn't it, the van der Waals force of attraction, or the weak intermolecular force of attraction that require very low temperatures to do what? To break. So that may not require a higher melting point. So the attraction between the shared pair of electrons, isn't it? Now if you talk about a covalent bond, isn't it? We are tentatively referring to let's say even HH. A covalent bond, you have said, a bond between two atoms of nonmetals. There is equal sharing of electrons. The electrons are strongly attracted to the nucleus of the two atoms, isn't it? Then the attraction again between the shared pair of electrons also can constitute what we call a covalent bond. So a covalent bond can either exist between the shared pair of electrons or between the two nuclei of the two atoms which hold the electrons in position. Two nuclei of the two atoms which hold the electrons in position. Now they have said graphite is another substance that contains covalent bonds. The diagram shows the structure of graphite. Most covalent bonds or substances do not conduct what? Electricity. Explain why graphite is able to conduct electricity. It has one delocalized electron. It uses to actually conduct what? Electricity. We are saying the table shows the molecular formula of organic compounds A, B, C, D, and F. A, B, C, D, E, and F. So explain which homologous series compounds A, B, C, D, F belong. Of course, they are found in different what? Homologous series because of the way